Lesson 103 might be the most important lesson you've had for the past month. Not that it's the most complicated, but it's talking about a property you're going to use extensively into the following years of algebra. It's called the distributive property. Perhaps you've heard of it, perhaps you have not. It involves notations like this one, with a constant outside of a parentheses where we have expressions being added or subtracted, and how we can solve that further than what it is. To illustrate how this property works, take 4 times 2 plus 3. There's two ways you could attack this, and really the better way is the way you already know. 4 times 2 plus 3 would tell us multiply the outside by first adding inside the symbol of inclusion, giving us 5, to ultimately be 20, right? Well, we could also take 4 times 2 and 4 times positive 3, which this is 8, this is 12, multiply those out, sorry, not multiply, add those together, and that's 20. So we solved the same amounts by distributing 4 times 2 and 4 times 3, adding those products together, finding the sum of the products. In this case, that was not the better way to do it. This was quicker and easier. But what if 2 and 3 are x and y? You can't put them together. And yet we can show this one other way. We can show it as 4x plus 4y. Let's talk about that just a little bit more. Here is the problem you saw at the beginning. I cannot put these together. Why? They are not like terms. I have an x, a y, and a constant. But I can distribute it multiplying 4 times x, 4 times 2y, and 4 times the opposite of positive 8 or minus 8, right? So it's like saying 4 times x, 4 times 2y, and 4 times negative 8. You'll put all of these products together and find the sum of the products. 4 times x is 4x. 4 times 2y, 8y. 4 times negative 8 is a negative 32. Add them all together. We can't do anything at all, can we? So we're done. But this is a new way to show this. And that will sometimes come in handy if, let's say, there was an x hanging out on the other end, which would still be there. Now what can I do? Where I couldn't before, I have now released the x from the symbols of inclusion to allow it to be combined with the other one, and we could further reduce by showing a 5x. Does that make sense? That's just a hypothetical there. Let's try another one. The distributive property. Let's consider 3x, so a coefficient and a variable on the outside, multiplied by y minus 2 plus 2x. I don't know if the book will make you do anything beyond a trinomial in the parentheses for now. What does the distributive property tell me? That I don't have to be done, that I could show this another way, as we could take all multiplication out of our final answer by multiplying the outside by each inside and then summing it together. 3x times y is 3xy. 3x times negative 2 is negative 6x. You follow me there? 3x times negative 2. 3x times 2x, what is that? It's positive. Multiply your coefficients, 6. How many x's? X times an x is otherwise shown as x squared, right? This is your new final answer. You don't have to show an add sign here, and we already have one here the way I wrote it. Summing them all together. So the distributive property states that a factor on the outside of terms being added can also be shown as AB plus AC. Distributing means to multiply that outside by each term on the inside. Another way to show that is, because of the commutative property of multiplication, we can distribute backwards and say AC plus AB, which is going to be the same thing. Two ways to show that distributive property. To distribute looks like what we just did. And we're going to be doing that all the time. Why don't you try practice problems A through C, and you'll have the problem set for tomorrow. Show me that work. Show me the answers. Ask friends questions first. Ask me if you're still confused.